For activity 115B, circuit theory simulation, you will have to learn how to use multisim to build a virtual series and virtual parallel circuit and take measurements for voltage and measurements for current. Multisim is installed on all the computers in the lab, and you should be able to find it by going to your Start menu and clicking on Multisim 14. Once you do, you will get what appears to be a large sketching work surface. There's a lot of small icons for shortcuts along the right-hand bar. Along the top is a standard Windows drop menus. Along the left-hand side is what will pass as a browser bar that tells you what design you're working on and what sheet you're on. Multisim is a full design simulation package for electronics, and as such, you could have multiple circuits on multiple sheets, all as multiple layers or extensions of a larger project. Most of our projects will be quite simple in their scope, and they usually will involve one or two sheets. So let's go back to the circuit. They show you a sample series circuit, a sample parallel circuit with all currents and values labeled. But for us, we're going to start with something simple. We will start with this circuit. This circuit contains a 12-volt voltage source, a 12-volt DC battery source, a 220 ohm resistor, and a 470 ohm resistor. In addition, it has a reference ground point. Multisim needs reference ground to be able to do its math computations. We've ignored this for our purposes on hand calculations. So, where to find these components? If we go to Multisim, we go across the top to Place. You can ask to place a component. In the component drop-down window, there's a lot of options, but please make sure that your database is set to master and that your groups, this is where you can filter and reduce the list to something more manageable. Today, right now, we're going to click Sources. And from Sources, we're going to click Power Sources. We need a battery after all. From Power Sources, you will see AC power and DC power. Well, DC power looks like the classic battery icon, and indeed it is what we need. We click OK. Once you click OK on any icon in Multisim, you'll return back to the work surface as to where you're going to place a component. While you can place it literally anywhere you want, I find it's easier to I find it easier if I place it in the wrong place. I can move it. I can delete it. I can undo deletes. It's pretty much a lot of copy and paste, similar to some parts of it Word. You can zoom around the workspace. You can click and grab around workspace. I'm going to put it right there. Now, on my particular copy of Multisim, it appears that all my labels are off. I'm going to click anywhere on the workspace and click Properties. And I'm going to put my values, reference definitions, and labels back on. And click OK. That way I can see that I place voltage source 1, and right now it's actually set to 12 volts. That's going to come in handy. I then go on and see what else I need. I need a ground source. Go back to Multisim, Place, it's actually reference ground, Component, Power Sources. It usually remembers where you last left off, so if it's in the same family and group, you're going to find it right away. There's a digital ground source as well as a regular ground source. Since the picture shows regular ground, we'll take regular ground. Click OK. So now you can place it anywhere you want, but since we want to recreate the circuit, we're going to use the guiding buttons to place it right there. Let's close for a second and look, see what else we need to do. We need a 220 ohm resistor and a 470 ohm resistor. Let's go ahead and go back to Multisim. This time we're going to go back to Place, Component. We'll always be on the master database, so we won't have to alter that, but it's the group one that we'll have to change. Let's drop from Sources. Resistors are basic components, so we'll click Basic, and then we'll scroll down here to Family and look for the resistor family. There it is. Click on Resistor. Immediately, you get all sorts of odd little numbers on the side, and it's be a little annoying having to try to scroll up to find a 220 ohm resistor. So instead, we're going to help things along here. In the component search bar, we could just type 220 ohm, and you'll see that it filters out, and you can actually choose a 220 milliohm, a 220 kilo ohm, or 220 ohm. The symbol is ohm. Multisim does know SI prefixes, and I've never seen a 220 milliohm resistor. It's either 220 or 220 kilo. Well, we'll just take the normal one. In the little symbol window, you can already see that there's the resistor. Click OK. Our mouse is holding it until we place it somewhere. We'll place it somewhere about here. Click. And then the next component was supposed to be 470 ohm. Click. And then we place it somewhere around here. And that's all we need at this time. Close. Now, if you look at the circuit layout, the R2 is not horizontal but vertical, and it'd be nice to be able to connect the circuit the same way. So we go back to our multisim. We will click on the R2. You can be careful. You can click on the label, you can click on the value, or you can click on the whole component. And make sure the box is covering the whole thing. Right click on R2 and then ask it to rotate clockwise. And now it looks a lot more like the circuit. Move it a little bit, space it out. There we go. For multisim, we connect everything as if we were sketching straight lines, perpendicular lines, and connect. As you get closer to a circuit and you go to connect, the crosshairs, the pointer becomes a set of crosshairs to let you know that you can start a trace. Click, connect, click. If you need to connect, make a turn, the auto router for traces on multisim can be quite annoying, and sometimes it'll try to, well, I want to click down here. Well, I can click in between a path to set a fixed point in my trace, and then click to connect, and then click to connect. And there's our basic first circuit. Right now, though, there's not a whole lot to see as there's not a lot going on. If I wanted to begin the simulation, and indeed Multisim is a simulation package, once you design something, once you lay out a design, you can start the simulation by hitting Run, F5, the green icon. You can go over. Some of them have a switch icon here to turn it on, but more often than not, the green tab will run. Let's click Run, see what happens. Nothing seems to happen. Unfortunately, there's not a whole lot of excitement going on right here. Down in the lower corner, Multisim keeps track of local time being time to the specific design. You see the little green bar bouncing back and forth. In the browser bar, a green arrow blinks at the design that's active. You could be working on multiple pages and not realize that which page is actually the one that's running the simulation. So let's go ahead and turn this off. Now we want to be able to go and take some measurements. While we built that, we want to be able to measure how much current I sub t is coming out of the battery and how much voltage at R1 and R2. So we will need to hunt down these little weird box icons. These are actually our meter icons. Instead of a multimeter, we will actually use a voltmeter icon that's denoted by V, another voltmeter icon, and finally an ammeter to measure amps and current that's denoted with an A. Let's show you where you can find those. If you go to Place, Component, and this time on the group window you drop it down to Indicators. It looks like a little small 8 indicators. You get options. Some of them are light bulbs, some of them are displays. We want a voltmeter. And you see the symbol, it switches automatically. There's 4 basic ones. The horizontal voltmeters, horizontal that reads positive and negative from left to right. There is the voltmeter that reverses that, and it goes negative, positive. There's the vertical voltmeter and reverse voltmeter. We will take the horizontal voltmeter first, click OK, and I'm going to scroll up. Let's close here for a second. My voltmeter ran away from me. I'm going to put it up here. It's a little crowded. Maybe I should select my entire design and drag it down a little bit to give myself some space. Put my voltmeter here. We need another voltmeter. Place, component, a vertical voltmeter this time. Click OK and drop here. We also needed a current meter, also known as amp meter for amperage. We click on that and we get the regular horizontal one and click OK. And then we close. The numbers underneath these meters indicate their inherent nature property for resisting, ability to how well they avoid interfering in the circuit. For our purposes, we don't need to be too concerned with those. We just need to be able to read the values. We need to read the numbers. Voltmeters are easy. They connect across the resistor you want to measure. This one, U2, will measure R2, the 470 ohm resistor. U1 will measure R1, the 220 ohm resistor. Well, if you remember your drawings from the practice problems, current doesn't go through an element, doesn't go through a component. Current is what is flowing through this red wire. So what we need to do is make a little change to the drawing. We need to actually insert our current meter into the design. We actually need to lower this until it turns teal at its ends, and we let go. And now our current meter is inserted in our design. We know this to work if we go ahead back now to play. And now we have some values. Our 12 volt battery is putting out 0.017 amps of power through our series circuit. Our two resistors, well, I could have asked you to solve for R sub t to calculate this value. Instead, our two resistors still cause that to happen, but now you can read that this has 3.872 volts across it. This resistor has 8.174 volts across it. If we also check Kirchhoff's law, we will see that adding this voltage plus this voltage should be pretty darn close to the source voltage. This has been the preliminary setup. We'll go on to video 2.